January 17, 1940. Toledo, Ohio. Snow drifts against the weathered brick walls of the Willys Overland plant as the morning shift whistle pierces the bitter air. Inside the echoing factory halls, the metallic symphony of hammers on steel mingles with the acrid scent of welding torches. Delmar Barney Roos, chief engineer of a company teetering on the edge of bankruptcy, hunches over blueprints spread across a scarred wooden table. His calloused fingers trace the outline of what would become America's most crucial weapon. Not a tank, not a fighter plane, but a quarter-ton utility vehicle that would carry democracy on its steel backbone across two hemispheres. The sound that would define this moment was not the roar of artillery or the drone of bombers, but the steady plink-plink-plink of a coffee can collecting water from a leaking roof. Each drop counted here, where every penny mattered, and every engineering decision balanced on the razor's edge between innovation and extinction. Roos lifted his eyes from the drawings, unaware that his next 75 days would birth a machine that would make Adolf Hitler himself curse American ingenuity. 3,000 miles away, in the sterile conference rooms of the War Department, military planners faced a problem that kept them awake at night. The Wehrmacht had overrun Poland with mechanized precision. Their Kubelwagen utility vehicles darted across European battlefields like mechanical wolves, carrying supplies, communications, and command authority wherever the Third Reich's ambitions demanded. America possessed no equivalent. The Army's existing vehicles were either too heavy, too complex, or too fragile for the kind of warfare erupting across the world. The military specification that landed on Roos's desk in July 1940 read like a mechanical impossibility. Build a vehicle weighing no more than 2,300 pounds that could carry a 600-pound payload, traverse any terrain, maintain 50 miles per hour on roads, and climb a 60-degree grade. The Army wanted 135 companies to bid on this contract. Only 3 dared to try: American Bantam, Ford Motor Company, and the struggling Willys Overland. The deadline was impossible: 75 days from contract to prototype. Most automotive projects required 2 years, but Barney Roos possessed something his competitors lacked: desperation married to genius. The son of Dutch immigrants, he had clawed his way through Cornell University on merit alone, earning dual degrees in mechanical and electrical engineering while competing as a championship fencer. His resume read like a catalog of American automotive achievement: Locomobile, Marmon, Pierce Arrow, 11 years at Studebaker, where he had revolutionized engine design. When Willys Overland recruited him in 1937, the company was selling factory buildings to pay operating expenses. Chairman Ward Kennedy had once berated engineers for wasting drafting paper. In response, Roos had physically lifted the penny-pinching executive and deposited him in a wastebasket. The message was clear: genius would not be constrained by bureaucratic timidity. Roos's secret weapon was already humming on the factory floor: the Go Devil engine. Originally developed from the 1926 Whippet 4, this 134-cubic-inch power plant had been reborn through Roos's methodical improvements. Insert bearings replaced the old Babbitt bearings, a counterweighted crankshaft eliminated vibration, lightweight aluminum pistons reduced reciprocating mass, and full-pressure lubrication ensured reliability under the most punishing conditions. The engine produced over 60 horsepower at 4,400 RPM and had proven its durability through 100-hour dyno tests that would have destroyed lesser motors. On September 23, 1940, the first Bantam prototype rolled onto the testing grounds at Camp Holabird, Maryland. Army observers watched as the tiny vehicle, nicknamed the Blitz Buggy, scampered up grades that had stalled trucks twice its size. But Willys Overland engineers stood in the crowd, notebooks in hand, absorbing every detail of their competitor's design. When the Willys prototype arrived 2 months later, It incorporated everything Roos had learned from watching the Bantam, plus the crushing advantage of the Go Devil engine. The Army brass knew immediately which vehicle would win the war. The Willys prototype outperformed both competitors in power, durability, and manufacturing potential. On July 23, 1941, Willys Overland received the contract to produce 16,000 vehicles designated the Model MB. Ford Motor Company would manufacture an additional 15,000. Identical units under license, designated the GPW, G for government contract, P for the wheelbase measurement, W for Willys design. But the real transformation began not in American factories, but in the hands of soldiers who treated their Jeeps not as sacred military equipment, but as mechanical clay to be molded by necessity. The first field modifications emerged almost immediately. Soldiers discovered that the rear of the vehicle couldn't support both a spare tire and a jerry can without structural failure. Field mechanics welded reinforcing brackets from scrap metal. When factory engineers learned of this modification, it became standard equipment. The windshield, designed to fold flat for concealment, proved too fragile for combat conditions. Mechanics reinforced the hinges with steel wire welded into place. Again, the factory adopted the field improvement. The jerry can became the symbol of American abundance. These 5-gallon steel containers, originally a German design captured and improved by British engineers, then mass-produced by American industry, represented everything the Axis powers couldn't match. Where German forces hoarded fuel in inadequate containers and Japanese troops carried water in bamboo tubes, American Jeeps bristled with jerry cans filled with gasoline, water, oil, and sometimes coffee or soup. Each can represented not just logistics, but industrial capacity, the ability to produce, fill, ship, and replace essential supplies faster than any empire in human history. Technical Sergeant Frank Morrison of the EE, 82nd Airborne, discovered this reality. During the Sicily invasion in July 1943, his Jeep had taken shrapnel through the radiator during a Stuka attack near Gela. With enemy forces advancing and no replacement parts available, Morrison improvised a repair using a damaged jerry can, some rubber tubing salvaged from a downed aircraft, and mechanical ingenuity born of desperation. He hammered the punctured can flat, creating a makeshift radiator that channeled coolant through the engine block. The repair held for 6 days of combat operations, long enough for proper parts to arrive via the American supply chain that turned impossibility into routine. Morrison's field repair exemplified the fundamental difference between American and Axis mechanical philosophy. German vehicles were precision instruments, engineered to exacting tolerances and maintained by specialists with proper tools and factory parts. When a Kübelwagen broke down, it required a trained mechanic, correct replacement components, and time, luxuries that became increasingly scarce as the war progressed. Japanese equipment followed similar principles, built for specific conditions and dependent on complex supply chains that Allied submarines and bombers steadily severed. American Jeeps, by contrast, were designed for field repair by soldiers with wrenches, hammers, and whatever materials they could scavenge. The Go Devil engine used common tools for maintenance. Parts were interchangeable not just between Jeeps, but often with civilian vehicles. When proper components weren't available, American mechanics improvised. Jerry cans became fuel tanks, radiators, even armor plating. Telegraph wire replaced electrical components. Ammunition cans served as toolboxes, first aid kits, and cooking pots. Colonel Heinrich Müller of the 21st Panzer Division learned this lesson during the Normandy campaign. His unit had captured several American Jeeps during the initial fighting around Caen. German mechanics examining these vehicles expected to find crude, hastily built machines, American quantity over Germanic quality. Instead, they discovered something that challenged their fundamental assumptions about industrial warfare. The Jeeps were robust yet simple, powerful yet economical. sophisticated in concept, yet maintainable by teenagers with basic tools. Mueller wrote in his journal, dated August 3, 1944, "The American Jeep represents something we failed to understand about our enemy. It is not crude machinery, as our propaganda suggests, but machinery designed for a different kind of war, one where replacement and repair matter more than initial perfection. Our Kübelwagen is superior in many ways, but when it breaks, we need parts, tools, and time we no longer possess. When their Jeep breaks, any farm boy with a wrench can make it run again. This is not American weakness. This is American strength we underestimated." By 1944, German forces valued captured Jeeps above almost any other American equipment. Field commanders ignored regulations requiring captured vehicles to be turned over to rear echelons. Frontline units painted iron crosses on Jeep hoods and used them for reconnaissance, supply runs, and command transport. The irony was unmistakable. Vehicles that Nazi leadership had dismissed as evidence of American industrial inferiority had become the most prized trophies of Wehrmacht and SS units. The Jeep's transformation from utility vehicle to war machine accelerated with each field modification. Soldiers mounted 30-caliber machine guns on pedestals welded to the passenger seat. They fabricated armor plating from salvaged steel, creating improvised combat vehicles that could engage enemy positions while maintaining the speed and maneuverability that made Jeeps invaluable. Radio operators installed communication equipment in the rear cargo area, turning Jeeps into mobile command posts. Medical Corps units converted them into ambulances capable of reaching wounded soldiers in terrain that defeated conventional vehicles. Lieutenant Colonel George Patton III observed this evolution. During the Sicilian campaign, writing to his father, "The Jeep has become whatever our soldiers need it to be. I have seen them used as artillery tractors, reconnaissance vehicles, ambulances, command cars, and assault platforms. The enemy adapts his tactics to our equipment. We adapt our equipment to victory. The Jerry can remain central to these adaptations." American soldiers discovered that these containers could serve functions their designers never imagined. Filled with sand, they became improvised armor plating. Packed with explosives, they became demolition charges. Cut and shaped, they became field stoves, wash basins, and storage containers. Most importantly, they represented America's logistical abundance, the industrial capacity to produce millions of standardized containers and fill them with whatever soldiers needed, wherever they needed it. Staff. Sergeant Anthony Benedetto of the 63rd Infantry Division witnessed this abundance firsthand during the crossing of the Rhine in March 1945. His unit's Jeeps carried not just ammunition and medical supplies, but jerry cans filled with fresh water, coffee, cigarettes, candy bars, and even ice cream mix. German prisoners, accustomed to ersatz coffee and sawdust bread, stared in amazement at American soldiers casually discarding half-eaten chocolate bars. One Wehrmacht veteran told Benedetto through an interpreter, "We knew the war was lost when we saw how much food you could waste." This abundance reflected more than American wealth. It demonstrated industrial organization that the Axis powers couldn't match. Between 1941 and 1945, American factories produced 640,000 Jeeps, constituting 1/4 of all military support vehicles manufactured during the war. At peak production, Willys and Ford combined were completing one Jeep every 90 seconds, 24 hours a day. This rate exceeded the entire annual vehicle production of most nations. The numbers told the story of democratic industrial power. $363,000 Willys MBs, 280,000 Ford GPWs, manufactured by workers who understood that their labor directly supported sons, brothers, and neighbors fighting overseas. Factory shifts ran continuously, with workers voluntarily extending hours and contributing overtime pay to war bond drives. Women who had never seen an assembly line became precision welders and engine assemblers, Teenagers, fresh from high school, learned to operate machinery that mass-produced the vehicles carrying democracy to distant battlefields. Soviet engineers who examined captured jeeps under the Lend-Lease program reported findings that astonished Moscow. The vehicles demonstrated manufacturing techniques that Soviet industry, despite its massive scale, couldn't replicate. American production methods achieved both quantity and quality through standardization, interchangeable parts, and quality control systems that ensured reliability without sacrificing speed. Most importantly, the Jeep's design philosophy prioritized field maintainability over laboratory perfection, exactly what mechanized warfare demanded. By late 1944, the psychological impact of American Jeep abundance had penetrated Axis consciousness at every level. German soldiers fighting in the Ardennes offensive discovered American supply dumps containing hundreds of Jeeps, many still in shipping crates. Japanese defenders on Pacific Islands watched American forces unload Jeeps from landing craft in numbers that seemed mathematically impossible. How could one nation produce so many vehicles while simultaneously building ships, planes, tanks, and the entire arsenal of modern warfare? The answer lay not in American resources alone, but in the democratic organization of those resources. Soviet production achieved impressive quantities through centralized command, but Soviet vehicles reflected the limitations of totalitarian engineering, designs approved by political committees, rather than tested by users. German engineering produced superior individual vehicles, but Nazi industrial organization couldn't adapt quickly to changing battlefield requirements. American democracy created a feedback loop between factory and battlefield that continuously improved equipment based on soldier experience. Corporal James Macready of the 1st Armored Division experienced this feedback loop personally during the Italian campaign. His Jeep's transmission had failed during mountain fighting near Monte Battaglia in October 1944. Macready submitted a detailed field report describing the specific failure mode and recommending design modifications. Within 3 months, engineering changes based on his report and similar feedback from other soldiers appeared in production vehicles. Macready later wrote, "The brass actually listened to what we told them. Our ideas made it back to Detroit and came back to us as better equipment. That's when I knew we were going to win this war." This democratic approach to military engineering confounded Axis strategists who assumed that American softness would handicap military efficiency. Instead, American willingness to acknowledge mistakes and incorporate improvements from common soldiers created a learning organization that adapted faster than any military bureaucracy in history. German and Japanese officers, trained in rigid hierarchies where subordinates didn't question superior decisions, couldn't replicate this adaptive advantage. The Jeep's symbolic power extended beyond its mechanical capabilities. For American soldiers, these vehicles represented home, Detroit assembly lines, Toledo factories, the industrial heartland that supported their mission. For Allied populations, Jeeps meant liberation was approaching. For Axis forces, they represented the inexhaustible material strength of an enemy they had underestimated. For neutral observers, they demonstrated that democratic societies could organize for total war without abandoning the values that made victory worthwhile. Captain Wilhelm Schröder of the Afrika Korps recognized this symbolism during the final retreat from Tunisia in May 1943. His panzer regiment had been destroyed by Allied air attacks, and he was escaping on foot through the desert. An American Jeep patrol found him, nearly dead from dehydration. The soldiers gave him water from a jerry can, bandaged his wounds, and transported him to a prisoner camp. Schröder wrote in his post-war memoir, "They saved my life with water they could spare because they had so much. They used their most valuable vehicle to transport one enemy prisoner because they had so many vehicles. This was not military necessity. This was abundance used humanely. I understood then why they would win." The final test of American Jeep superiority came not in combat, but in the immediate post-war period. As Allied forces occupied Germany and Japan, American Jeeps continued operating while Axis vehicles fell silent. German Kübelwagens, precision-built for European roads, couldn't obtain replacement parts with their factories destroyed. Japanese equipment, designed for specific tropical conditions, failed in the varied climates of occupied territories. American Jeeps, supplied by an intact industrial base and designed for field maintenance, kept running. In the Philippines, former Japanese soldiers watched American mechanics rebuild captured Jeeps using parts salvaged from wrecked vehicles, jerry cans, and scrap metal. These improvised repairs often restored Jeeps to better condition than their original factory specifications. Filipino mechanics learned these techniques and began converting surplus Jeeps into civilian transportation. The iconic jeepneys that still dominate Philippine roads today, living testament to American engineering, philosophy that prioritized adaptability over perfection. Sufi China, Jeep's transformation from desperate wartime expedient to global icon reflected the larger transformation of American society during World War II. The same industrial democracy that could respond to soldier feedback with engineering. Improvements also proved capable of organizing continental resources for sustained global conflict. The same abundance that filled jerry cans with whatever soldiers needed also demonstrated to the world that free societies could outproduce totalitarian empires without sacrificing the freedoms that made victory meaningful. Staff Sergeant Morrison, the mechanic who had improvised that radiator repair in Sicily, survived the war and returned to Toledo, where he found work at the same Willys Overland plant that had produced his Jeep. In 1946, he helped manufacture the first civilian Jeep, CJ-2A, powered by the same Go Devil engine that had carried him through North Africa, Sicily, and France. The assembly line where he worked produced Jeeps for farmers, ranchers, and construction companies, peaceful applications of wartime technology. Morrison kept a dented jerry can on his workbench, a souvenir from the Sicily campaign. Inside, he stored the tools he had used for that desperate field repair: a ball-peen hammer, wire cutters, and an adjustable wrench. These simple implements, multiplied across thousands of mechanics in dozens of theaters, had maintained the mechanical backbone of democratic victory. When younger workers asked about the war, Morrison would tap the jerry can and say, "This is what won it. Not the bullets or the bombs, but the tools and the parts and the know-how to fix anything, anywhere, with whatever you could find." The jerry can's metallic ring became the sound of peace. Mechanics tuning engines, farmers repairing equipment, construction workers building the infrastructure of prosperity. But it retained the deeper resonance of democratic strength, the industrial capacity to produce abundance, the social organization to direct that abundance toward human needs, and the cultural values that used abundance responsibly. Today, as the last World War II veterans fade into memory, their Jeeps persist in museums and private collections, testament to engineering decisions made in desperate haste 3 generations ago. Each surviving vehicle carries the accumulated wisdom of soldiers who transformed utility into victory through mechanical ingenuity and democratic adaptation. The Jeep's legacy lies not in its specifications or production numbers, but in what it represented: a society that could listen to its citizens, adapt to their needs, and organize its resources for purposes larger than material acquisition. The and plink, plink, plink of water dripping into that coffee can in Barney Roos's factory had marked time toward a deadline that seemed impossible. But American democracy had always specialized in achieving the impossible through the accumulated efforts of individuals who refused to accept limitations as permanent. The Jeep became unstoppable not because it was perfect, but because it was perfectible, designed for improvement by the people who depended on it most. In the end, Hitler's 1,000-year Reich lasted 12 years, Stalin's Soviet Union collapsed after 7 decades. Imperial Japan surrendered after 4 years of total war. But the Jeep endures, still carrying people and cargo, still being modified and improved, still demonstrating that the most powerful weapon in human history is not destruction, but the organized creativity of free people who refuse to accept that problems cannot be solved. The Jerry can sit silent now in countless garages and workshops, no longer filled with the fuel of war, but with the lubricants of peace. Yet its metallic voice still whispers the truth that saved civilization. Abundance shared becomes strength multiplied, and strength multiplied in freedom's cause proves unstoppable against any tyranny that dares challenge the democratic spirit of human ingenuity.